returning to the problem. Hold on a second. I just remembered something. There. That should resolve other problems. Noticed in the past 2 episodes, you can barely hear me over the sound of the machinery. First, I want to recheck where we are. Yes, here. This. You see, any one of these where we have something we need to take in, alter slightly and then put back out, and it's on a line like this. There's a lot of these. I have a problem with all of them. And right now we're having a timing problem. In fact, we can just select the time like this. We don't need to alter the entire track. There. Let's see how this works. Probably not well. Yes. So notice these are coming in too early. That's not good. Also, this is in the wrong place, I just now noticed. Going to alter that. What is this mess? Oh, I know what happened. You... I can already tell what this level is going to be like. And we've already... I don't even remember how long we've been working on this. Probably half an hour already. Why is this here like this? I don't even remember. It should be like this at least. Probably more like this. Oh, now I remember why this isn't here like this. It blocks the path. Need to find a way to fix this now. I can think of one way, perhaps. Actually, it would probably be best if we lowered the speed. We're already having problems, we don't need any more problems on top of that. There. New problem, misalignment. On the second one, I believe it is. There. This, yet again, coming in too early. Which means that this is coming in too late. Well, that should help. This seems to be working, finally, except now. There's an error here. Technically we don't need this one anymore. But we do need something holding this up still. Oh no. What a disaster. I need to revise all of this. This is... Everything needs to be destroyed and reconstructed. I don't want to look at this anymore. Sometimes you just need to destroy everything, and only then can everything be fixed. I don't want anything residual. There. And now... still going to have this be like this though. That part worked. There's nothing wrong with this module. There. An outline of what needs to be where. And these to keep track of alignment. Actually, if I do it like this, there'll be two stations here and here. Oh, and if I have them only activate when the system is ready for them, that would resolve the synchronizing problem. Because we had an asynchronous system, and that was causing the problem. And so there was no coordination. And so here is where we need to place the interrupt in order for this to be aligned correctly. Actually, this may be too far. There. Now we don't need these anymore. And this can be placed here. No, actually that would interfere with that one. Taking a shortcut through here, and then through here, like this. And that's how that's going to work now. Only now it's... yeah, timing is incorrect again. Now it's not. Oh, but I'm remembering something also. They need to be slided in from the side in order for them to be welded on. Because remember, there are only a few ways you can weld things together. And in this case, you can weld from the ceiling here because this is a flat surface. But I don't think you can weld from any other point. And because of that, actually, you could place one welder here and another one there. That would work. Actually, why not? Actually, I can just... Control Z. I wonder how many backups it saves. Because it can only store a certain number of undos. Well, assuming that it's taking advantage of the huge amount of RAM memory it has access to, probably hundreds of undos, so we're probably not going to be in any danger anytime soon. But because of this new method, we're going to need to change this slightly. There. Like this. There. And now this way, we can bring this down here, like this. here, and then have these be here. So that they can come in from the top, but also be welded on. And this will be better like this. Yeah, like that. And then once that happens, I can immediately send it back out again. Have this be on the other side. There. I see how this works first before making any more alterations. Oh, I see what the problem is here, which we can actually fix now, because I moved where that is. And so now that there's no longer an interference there either. The new problem is that you can't halt any of the ones behind this one, and they're not timed at all. There's that air gap initially, but it gets... yeah, the air gap is destroyed upon them slamming together like that. There needs to be something here to block the one behind it from entering before it's ready. Oh, I know. They can bring it in from here. And so when there is something in the station, it won't allow anything new into the station. There. New problem. The air gap behind that one is destroyed also. And it propagates outward. Oh, I have a new idea. Hold on. Instead of that, what we can do instead is first get rid of this redundant ring here, and actually shorten this cable because it doesn't need to be so long. Now, with this, we can actually push the one behind out of the way. From probably here would be a good enough gap. So watch how this works. And there should also be something to bring it back in from here when it's ready. There. And so now it's pushed out of the system. How about what's this? Oh, you're in the way now. How do I fix that? This is a whole new problem. Oh, I think I know how. There is one small problem. Now, the air gap again. It will require enhanced thought. Oh, you. I need you to be here instead of there. One space back. So that this will be aligned correctly now. Yes, like that. Only now this is back to being asynchronous. Well, technically it's synchronous, just not in the right way. And it activates too early now, you see. Which means we need this part back here to be delayed. And how would that be done? It becomes the question. And this was... actually, if we move all of this ahead one block, that would solve the problem immediately. And all I would need to do is remove this block here. Temporarily move all of this to the ceiling so it's out of the way. And place one grab point here. And move all of this forward by exactly one block. And that's problem resolved. There. fixed. And now it functions correctly. Look at that. I'm not sure if this is needlessly complicated or not. Oh, I see a problem. There was a problem emerging in the upper construction area, but it didn't interfere, so that's fine. The cycle score is higher than usual. I was expecting it to be lower than usual. The footprint looks normal. You know, it's a way to propagate these signals without using block score. Now watch this. So, there's a method of Yes, you see what I'm doing now. The only problem is it has a 1-tick delay, which wires do not have. But this can push signals arbitrarily far without using block score because platforms don't count as blocks. For some reason. Perhaps they should, or perhaps they shouldn't. Yeah, but in any case, continuing. You can actually just emulate the action of the blocker by having an inversion, an inverter gate before a regular piston, which I can also show. In fact, a very minor technical error, nothing to worry about. About what I was saying before, the inverter signal. It requires some logic, but it's not too intensive. In this case, you're pushing something out of the way instead of into the way of this. And so you see, when there's no input to this system, it's extended, but when there is an input, it's retracted, just like a blocker normally would be in this configuration. The only real difference is one takes one logic gate and the other one doesn't, and so it's more efficient. Making this thing. First I'm going to maximize the speed. And this room is very awkwardly shaped. Some kind of no sane person would ever design a building like this. And now, oh, I know, I'm gonna push this back by 1. So we're going to construct all of these modules separately and then append them at the end. So this one's been constructed correctly now. Yes, so that will be ready. I know how to do this one, it's easy. Oh, this one would be best stamped like this. Actually, oh, I see. So this, I would prefer to move back by 1 like this. And then this one, because it's the most complicated one, should be done very carefully and be given a lot of room. So first we want all of these activating simultaneously. Oh, and also if we move all of this down by one, it'll make the logic for it much simpler. And we want this to be here. So now watch what happens. Oh, never mind. Not there. Where was it? First, let's just watch the pattern of how it constructs. Oh, here. Actually, this should all be moved back up by one. It should be placed here. And here we should have this. Yeah, you'll see why. Not there. Here instead. There. And so that's now functioning correctly. And now on the other side we can have it all be welded together in the stamp process and sent out like that. Very efficient. And leaving just enough room for this to get through. Oh, actually there's a problem here, as you can see. So we should move this forward by one and block this so that nothing escapes. And regarding this thing, this is very simple. And we can bring this out once it's done to be assembled. And it will all be routed to here. And one needs to be placed on top of the other, and so we can have this be assembled like this. And also brought back out by the next one. And so every time one of these is pushed in, it pushes the finished product out of the way. And as long as it's timed correctly, which this is not. I know how to do this. It's simple. I just need to synchronize them with this logic. And so now, it will only be dispensed when it's required. And then this can be pasted onto the end of that here, and then brought back out of the way. In fact, this can all be pushed back by one to a line. And then this would go here, and this actually needs to be like this, because I'm pretty sure that's the only point where you can weld it onto it. Oh, I forgot this part. And this needs to be delayed by one because of timing. Actually, I'm pretty sure that also needs to be synchronized, because if I don't synchronize everything, it's going to be an asynchronous system, and it's going to corrupt itself. And that's a problem. That requires more logic, which requires more blocks. And because of that, it's going to be more expensive. And just to make sure it doesn't overflow. And the routing. This is correct. And now we can just send this to the output, as it is now complete. This is not a good solution, by the way. Oh. Yes, it requires far too much logic in order to run correctly. As you can see, the footprint and block scores are horrible, and the cycle score isn't even that much better than usual. And so, this one I would actually prefer to redo. And some modifications we can immediately make to make this much better would be things like firstly, getting rid of the need for synchronicity, because that was causing problems. And redoing all of these to be as they were before, what they were supposed to be. There. And finally, this. I know a better way of doing it. So first, you should weld these two together in a column, and then weld 3 of those together in rows to make that more modular, breaking it down into more individual steps. And of course, this system is great because the input pushes the complete product out of the way yet again, which is self-regulating. And now, for this part, it's even simpler, because you only need these welders here, and yet again. Yes, look at that. We don't even need a stamp. And I'm pretty sure this is all synchronized naturally, because there isn't any waiting or unnecessary steps remaining. To route them correctly. That's correctly timed, so we can just do this. And just making sure that that's correct. It would appear that actually, it should be easier if we reduce the speed. There, now everything is synchronized correctly. And now I need to see when we can put in the console. Oh, and this doesn't need to be reduced anymore, so I can just put that in immediately. And we can place these here. In fact, we can consolidate all of this into 3 instead of 4. And then once that's complete, we can just immediately bring that back out and send it this way, like before. And this is not good for footprint, by the way. This routing. Oh, actually, there is a problem here. I think this will fix it, though. Yeah, that is, if these would come in faster. So I can actually just do this. That's not good. Perhaps one too fast. There. Now it's perfect. Yes, now it has a better footprint score, a better block score, and better cycle score, all of them. And of course there's a very large number of ways to improve this still. This is not great. Yeah, but I'm going to leave it as it is for right now because I don't want to expend any unnecessary effort on it right now. We have other things to do, like this thing. I remember this thing. Oh yeah, have I mentioned that I've played most of this game before? I've just never beaten it because the end part gets very thick, very dense. This I would prefer to keep as minimalist as possible. The way I would usually do this is first by doing that. Now that's prepared. And also timing all of this is going to be important. The way I usually get rid of those waste blocks is by having this eviscerator stamp here. Need to make sure it's in the correct position. And I just need to take a look. Yes, that's correct. And we only need one more in this position here. And that can activate only when this first enters. Yeah, but no time else than that. And so I usually use this monostable setup for that. There, and now watch. A perfection. And we can place the welders for all of this on the other side. Right here in this row of 3. For when we put in the new parts. That's too far away, actually. And in this case, I don't think we need to have that be stamped in and just have it lay there like that. But this needs to be synchronized correctly for that to work. Yes, perfect. That's one part of the puzzle solved. And then have this part be here. Of course, synchronized correctly also. And something here to detect that the process has been completed by this last portion. And then after that we can release this part. Actually, this is going to have the same problem as the shuttle had. Now I can hotwire these two parts together. Oh, hold on. That's not far back enough. There. And of course, under the contingency that the air gap is broken. Like that. So now Oh, hold on. Oh no, that's not good. There, now it's not a problem anymore. Now for this part. Now to determine whether or not we need to delay this signal. Because if we do, then that's going to be extra logic. Actually, we don't need to delay the signal, we need to extend the signal's length. That's even more complicated, actually. So what I usually do to do that is, something like this. Similar to the monostable, but with 2 outputs instead of 1. And that should function correctly. Making sure that there is enough room for this. This floating portion. Actually, we don't need this here anymore because these welders support each other. Now let's see if it works. Yes. However, oh, that's not good. Yeah, that goes in too early now. What if... this timing is incorrect. And so that's going to need to be resolved somehow. I have a feeling this is going to be slightly more complicated than originally expected. This timing needs to be practically perfect for it to be synchronized. Now it's arriving too late. It needs to be perfect. Like that. One block more, actually. Like that. Yeah. Actually, the correct way to fix that is with this blocker here, so that can't push that back out of the way. And now we'll see if this is correctly synchronized. If it is. There. What a disaster. And it's very average. In fact, the block score is below average. But I don't want to spend any more time on this because I hate it. Oh, this one is actually one of my favorites. The whole room construction. So, what I usually do for this one is, first, I weld all of this together. Like that. And then, after that, I move it out. By first detecting when it's ready to move out, and then releasing the catchment, which should go right here. And there should be conveyors here. Also, there needs to be a blocker here to make sure that that doesn't get pushed back out of the way. And now we'll worry about this portion later on. So how I usually prefer to do this is with is inserting it like that. There's a correct way to do this. Yes, like that. And then after that, we should also weld it by right here. And now, in order to... Oh yes, I remember. In order to have it be timed correctly, we need to sense when it is welded together, and based on that, release the catching mechanism, which should go here. And yet again, a blocker to make sure that everything is not pushed out of the way again. Or maybe we do want it to be pushed out of the way and into another way. Here. Yes, and at this point we will be able to assemble these two separate portions into one portion. And that will be done like this. Yes, exactly like that. Actually, the welding process may not like that. Actually, no, there's no space there. For the welding at this point, let's actually pause. There's one point here that's available. There's this space here, but that's also where that travels through. And then there's this space here, but we need to go out through there. Perplexing. There is one idea I have though, and that is, actually no, it travels in through there. And so we would practically need one welder to be here, and just have the conveyor be there, and then bring another welder down from the ceiling to exactly this point here, facing the opposite direction. Like this. And then that's correctly welded together. Like that. And then it can be immediately fed out. Like that. Somewhat convoluted. And I think we can increase the feed rate by 3, and it will still work fine. Actually, it looks like it could handle 6. Let's keep going and see what the limit is. We can't know where the limit is until we hit the limit. That's not it. 9. No, the limit is exactly 8. Yes. And that's mostly average, except for the speed, which we changed manually, so that doesn't count actually. Or at least, to me, it doesn't. And now we can get another promotion. A top-down vertical writing system. It's so stupid. Sustenance. Additional sustenance. And back to work. Very efficient. Need to stay on schedule. Now, as for this... Oh, I remember this. This is just like that one other one, only now we have these blocks to work with, the lifters, which are very interesting. They allow for going back up after going down, or without going down in the first place at all. And so now we are not restricted to going down, we can also go back up again. Also going to increase the feed rate. Very good atmospheric music also, by the way. This is not correct. We require this as foreseen by that. This actually works much better than what I was planning. So I'm going to do this instead now. Yes. Excellent. And now, at this point, another idea. Yeah. So now I don't even need a piston to push it back out of the path. It pushes itself out of the path. And then this I can bring to where that needs to go. Oh, and also look, it can go infinitely up if the one going in pushes the one going out of the way. And so you don't actually need lifter ladders. You can just do this. Much more efficient. And this one we're going to route to this location to be affixed. And not there. Here. Here. And we're going to synchronize all of it like this, the typical method. Actually, when that pushes that one out of the way, it doesn't give any time for that to move in. So, yeah, that is a problem. In that case, you're going to need to rethink all of this. I know. Hold on. Instead of inserting it somewhere further along, we can insert it right here. Be careful not to delete anything by accident. And now this just needs to be timed correctly. Yes. And this can move down by one because that's a different system entirely now. One problem. These welders will interfere with each other. And so, what we actually want is to keep it elevated. And move this to here. And make sure it doesn't fly away. There. This should work now. Yes, it does. Almost without even overflowing here, which is pretty great. And I would prefer to route these to where they need to go first before doing all of that. I think we can actually drop them in from the ceiling. No, actually there's not enough room. So instead of there, I'm going to move it up slightly. And at this point there's actually a very simple way of pushing it back out of the path. And that's with this system here. It just detects the block and then moves it out of the way immediately, like that. And at this point we can route this to where it needs to go. With one delay here. Is that too much delay though? Is the question now. Perhaps a delay here instead will have a different effect. No, it has exactly the same effect. It's either too soon or too late now. As is visible here. Oh, I know how to fix this. Simple. We just need some delay synchronization. And one welder here. And then it's done. So we can just move it directly to its output location, which is here. And because of how tall this thing is, we can utilize that for this. Pushing the old one out of the way with the new one. So we don't even need a piston system. Simple. Cycle score, unnaturally good. Block score, moderate. Footprint score, terrible. The lifter adds a whole new dimension to these machines. Pun only partially intended, but no less reviled. There's this thing. This is simple by comparison to the other ones. The only thing that's awkward about it is the shape. Well, there's two ways to do this. We can build a solid block and then use eviscerators to carve out this shape. That would be subtractive manufacturing. Or we can do additive manufacturing, where we build all of these as separate pieces and then put them together. And each one has different complications. I actually think it would be best if we did it the subtractive way. So like this first. And we can have that all be welded automatically together first in rows, and then the columns can be welded together here. And because this is a three-dimensional object, there's a different kind of row that needs to be welded together. This isn't correct, however, because these interfere, which would not be a problem if we extended this out by one. There, see how this works. And placing this here will finish the system. And finally, because it's only 2 2 blocks deep, we can bring it back out at this point here. And that's complete. And to carve it out is very simple. First, I'm just going to send it through here, which will have 2 eviscerators here facing this way. And you'll see what that does. Yes, that's the first part of the shape. And then the next part can be very easily torn out of it. Right here at this elevation with this machine here. And so now that's all of the parts we need. Perfect. The only thing I'm disappointed with is how slow this mechanism is. There must be a way to speed there. There. And this all looks correct. In fact, we can reduce the block score even further by getting rid of all of these. And this one here. And this one. And this one. Yes, this looks correct. Actually, we don't need this one. I just noticed. This will be much slower, but also much less expensive. And then after this we can work on speed. There. Now look at the block score. It's unrealistically good. There is another way to increase the footprint score, and that's by doing all of this at the end. So that we have a large object for the least amount of time possible. I'm actually going to save this solution and create a new one. So we can save the old one. And in this one I'm going to run it at double speed by just doing this. Running the wire on top, it helps with footprint. And so now watch what happens. At this point, it would be best to have the stamps be out here like this. There. And now you can see how much faster that is. And I know exactly how to take advantage of this new speed. So, first, here, I'm going to place this assembler, which when it's done is going to feed this way here. This one is also going to have one that's going to be identical, and it's going to feed out to here as well. Actually, this is going to be offset by 1. Oh, that's a problem. The same problem as before, in fact. Just need to bring it out by 1. No problem, actually. There, and now you see it's much better this way. Very modular and extremely efficient. And we can actually do the evisceration right here to front load it. And then the final piece of the puzzle here. With these two. And then after that we can just route it directly to the output here. Complete. One small error here. Easily fixable. And that's the power of parallel processing. And now we see the footprint score is horrifying by comparison to before, but the block score is also the worst. The cycle score is the one that improved here. I feel like now is a good time to stop. It feels like it's been a long time.